In this next video, we'll look at applications involving mixtures. Now, some of the problems that we're going to do we've seen before, but when we had solved them, we used one equation and one variable. Now we could use two equations, two variables. So for the first one, number 10, the ticket office at the zoo sold 553 tickets one day. The receipts totaled $3,936. How many $9 adult tickets and how many $6 child tickets were sold? Okay, so we want to go ahead and set up variables to represent this situation. I wrote my variables out and I realized that I wrote student tickets instead of child tickets, so I'll go ahead and change that. We'll use C for child, and this is child tickets instead of student that I had originally written. Alright, so we're going to have two equations. One equation is going to talk about the amount of money that was made, and the other equation will talk about the number of tickets sold. It's the same kind of ideas that we had looked at last time we saw this kind of example. So we sold 553 tickets in one day. So that means the number of adult tickets plus the number of child tickets, A plus C, has to equal that total amount, which is 553. So now the second equation, A plus C equals 553, the second equation has to do with the money. So adult tickets are $9, child tickets are $6. So as we saw before, we're going to take the number of tickets and multiply it by the money. 9 times A plus 6 times C should total the $3,936 that we made. So 9 times A, $9 an adult ticket, $6 a child ticket, that equals the total that we had. So this system is a good candidate for either substitution or elimination, whichever one you feel the most comfortable with. If you're using substitution, you could take the first equation and write it as A equals or C equals. I don't mind using elimination here, so I'm going to go ahead and do that. I'm going to decide to eliminate C, so I'm going to multiply the top equation by -6. If you would like to use substitution, you can go ahead and do that. Or if you want to eliminate A here, you can do that. Let me go ahead and jump ahead and rewrite my system. Alright, so I rewrote my system here, multiplying this first equation by -6. Now I can add my equations together. The C's are eliminated. I have 3A equals, that gives me 618. So I'll go ahead and divide by 3. And A is equal to, that gives me 206. So I had sold 206 adult tickets. And I could go ahead and find the number of child tickets. I'll use that first equation. A plus C equals 553. I know that A is 206. So it means in order for me to find C, I need to subtract 553 minus 206. And that gives me 347. Let's make sure we answered the question. How many adult and how many child tickets were sold? Good, so we needed to find both of them. All right, so 206 adult tickets, 347 child tickets. All right, let's move on to number 11, another coin problem. Matilda has a handful of quarters and dimes with a total value of $8.55. The number of quarters is 3 more than twice the number of dimes. How many dimes and how many quarters does she have? Alright, so let's go ahead and define our variables by the quantities that we are looking for, the number of dimes and the number of quarters. So I'll use D and Q. Alright, so D equals the number of dimes, Q equals the number of quarters. So once again, we'll have two equations, one that talks about the value of the money, the coins that she has, and one will talk about the relationship between the number of dimes and quarters. Alright, so let's talk about the value first. So we have a total of $8.55, and we know that dimes are 10 cents and quarters are 25 cents. So let me write that. So 0.10 times D plus 0.25 times Q equals the total, which I forget now, $8.55. All right, so now we need another relationship. We have the relationship between the number of dimes and quarters. We're told that the number of quarters is 3 more than twice the number of dimes. So we can translate that directly. The number of quarters, Q, is equals 3 more than, 3 plus, twice the number of dimes, 2D. So that equation looks like so. Q equals 3 plus 2D. And so now we have our two equations, two variables. This is set up nicely for substitution because the second equation is solved for Q. So I'm going to take my expression for Q in the second equation, plug it in for the first equation. So now that first equation, 0.10D plus 0.25, I need parentheses here, 3 plus 2D equals 8.55. If you don't like the decimals, we can clear out the decimals by multiplying everything in the equation by 100. And I mean every term in the equation by 100. 100 moves the decimal point 2 places. I could pick any number to multiply by, but I just want to move the decimal point. I don't want to have to, do too much work. So this now becomes 10D plus 25. Inside the parentheses stays the same because that 25 carries that 100 with it and then will distribute in the parentheses. Equals 855. And that's just maybe to visually clean it up so you don't have to worry about the decimal points. You could certainly work with them and you'll still get the same thing. So I'll distribute that 25. And then we'll combine like terms that are on the same side. So we have 60D plus 75 equals 855. Let's go ahead and subtract 855 minus 75. Gives me 780. 60D equals 780. And then you want to divide by 60. And we get D equals 13. So that means we have 13 dimes. And I need the number of quarters. I have an equation that tells me about the quarters. I know that quarters is equal to 3 plus twice the number of dimes. So the number of quarters is 3 plus 2 times 13. 2 times 13 is 26, plus 3 is 29. So I know I have 29 quarters, 13 dimes. Of course, let's make sure we answered the question. And we did want to know, again, how much of each. All right, let's move on to number 12. Sammy has most of the ingredients to make a large batch of chili. The only items he lacks are beans and ground beef. He needs a total of 20 pounds combined of beans and ground beef and has a budget of $3 per pound. The price of beans is $1 per pound, and the price of ground beef is $5 per pound. How many pounds of beans and how many pounds of ground beef should he purchase? All right, so there's a very wordy question, but this is a question that we've seen before when we looked at mixing two different items to make a coffee blend or a party mix. So it's the same idea. So we want two equations. One equation is going to be about the quantity, about how many pounds, and the other equation is going to be about the money. The variables will represent the pieces that are missing, what we want to find, the number of pounds of beans and the number of pounds of ground beef. So I stated my variables. B will represent the number of pounds of beans, and G will represent the number of pounds of ground beef. We were told that we wanted 20 pounds in total, right? Total of 20 pounds combined. So that's actually our first equation. B plus G equals 20. The number of pounds of each combined has to be 20. The other equation is going to refer to the money. Now we have the value of per pound for beef and for beans and for ground beef, and we have the value per pound for the chili that we want. So the budget for the chili is $3 per pound. So that $3 is for the 20 pounds in total. So we want, our equation will be $1 per pound for beans, $5 for ground beef. All right, so let's put this together. So it's $1 for beans, $1 per pound. This is $1 here for the number of pounds of beans that we purchase, plus $5 per pound, $5 per pound for ground beef, $5 per pound for ground beef, and we want our mix, the 20 pounds, to be $3 per pound. $3 times the 20 pounds. Right, so the coefficients here represent the money, and the variables, and this 20 are the number of pounds. All right, so we have a system of two equations and two variables. We could use either substitution or elimination. I happen to like elimination, so I'm going to use that here. I'm going to eliminate the b because I only need to multiply the first equation by -1 to make the coefficients of b the opposite. Be careful when you multiply by a negative that you don't forget to change the signs of everything. So that first equation becomes -1b minus 1g equals -20. The second equation is the same. The only thing that I will do, and this is a 1 here, you know, those look, when you put them next to b's, they look like l's. The second equation, I'm just going to multiply the 3 times the 20 to get 60. And then combine these together. -1 plus 5 is 4, so 4g equals 40, which means that g equals 10. So I need 10 pounds of ground beef, and if I had 20 pounds in total, then I know that I should also have 10 pounds of beans. And that answers the question. Let's go on to the last one, the time that we have. All right, so here we have a percentage question. Natalia needs to make 250 milliliters of a 25% solution of a 25% solution of hydrochloric acid for a lab experiment. The lab only has a 10% solution and a 40% solution. Excuse these typos here in the storeroom. How much of the 10% and how much of the 40% solutions should she mix to make the 25% solution? All right, so the variables are going to represent the amount of each kind of solution. So let's set those up first. All right, so my variables, I went back to x and y here. X represents the number of milliliters of the 10% solution. Y is the number of milliliters of the 40% solution. And I went ahead and wrote the first equation, x plus y equals 250, because we were told that we had a total of 250 milliliters. Now these percentages, I want you to think of like money. So when we had money, we took the amount per pound and multiplied by the number of pounds. We're going to do the same thing. We're going to take the percentages and multiply it by the number of milliliters. So now we want a 10% and a 40%. We're going to change all percents to decimals, so move your decimal point 2 places for each of the percentages. And we want the mix to be a 25%. So let's go ahead and write that equation. All right, so here's what that equation would look like. So 10% of this many milliliters plus 40% of this many milliliters should equal 25% of the entire solution. So the percentage is the amount of chemical in that solution. So you can solve this system by either substitution or elimination. I'm going to fast forward that solution for you so you could see the answer, but then you'll check it along the way. All right, fast forwarding through that, again, feel free to pause this so you can walk yourself through the steps here. But I set up my system using elimination. I first got rid of the decimals just to clear things out, and then eliminated the x by multiplying by -10. I found y to be 125, and therefore x was also 125. So in this case, they happen to be the same.